Okay, guys. So let's say we have to convert from a base 6 to whatever it will come in 8. Now, the thing here is that we will not actually be able to do that. The reason is if you take 71 and do what we learned in the last time, it will get like 64 a base 7 and you will get a remainder of, say, what, 6, right? 6. And this is not divisible. So you'll get 67 base 8. If you multiply it back, you will not actually get the number that you would have hoped for, right? And the reason for that is pretty simple because this will give you the commencements in 10. You can't even check it for 6. The reason for that is very simple. This sort of division that we use, that is only applicable in the decimal system, right? So if you have this kind of a conversion, you'll first need to go to base 10, which we did 155, and then you will have to go to a base of 8. From 10 to 8, you already know how to do it. It's 155. You have 8 here. It will be divisible by 152, so you'll get a remainder of 3. And here the term would come in 19, which is again divisible, so you'll get 2, a remainder of 3 again, right? So you can then convert these things, but till then you will not actually be able to do it directly from 6 to 8, right? And if you do this, it will be 233. You will get 2 into 64 plus 3 into 8 plus 3. This is your 24. This will get you 128 and plus 3. So it should give you 155 back. So 3 plus 7, yeah, that goes 5. 2 plus 2 plus 1 carry, yeah, it's 155. So that is the thing. You can't convert directly because this particular division property is something that only applies to decimal, right? So this is the conversion. But is it necessary all the time? For some cases, no. For example, for conversion of base 2 to 8, and this is specifically good for people because there are certain times where you will be asked to convert decimal into octal directly. So in that particular scenario, decimal will only have numbers like this, right? If you have to convert it into octal, that is basically 2 to the power of 3. Because of that, you get a property where you can convert 3 bits in a go. So 101 and 011, you can convert these two directly into this base 8. Whatever the numbers these will give will be directly used for base 8, right? So you can say that this particular thing, base 2, is something which you can consider as this. And then you can just convert this thing into base 8, which is much more easier, right? So this particular thing, you can take it as, let's say, a 5, and this is a 3. Okay, and then this is a decimal, so you can convert this. Now this is in decimal form. You can directly convert individual numbers, which will be much easier to do. Since both of these are below 8, you can directly copy it out. So this sort of conversion is much easier, though you don't have to remember any of these tricks. You don't have to depend on it, because let's say if you don't have 6 values, you have 5 values only. Okay, if this is a scenario, don't put a 0 ahead, put a 0 behind, and you will still get that property holding. If you have, let's say, to convert it into base of 16, then that is 2 to the power 4. So in that case, make brackets of 4 digits from left hand side, right? Similarly, for 4, make brackets of 2 and so on. But these are specific tricks. You don't necessarily need to convert them. You will not get direct questions like from one base to other. If you do, if this case comes, then you can use this trick. But other than that, this is something which works all the time. Okay, so I hope that the base system is clear, and we'll see more questions when we come to practice area of this particular chapter.